This video is over lesson 17 in module 3 for Eureka level 7-8. We're going to be applying the Pythagorean theorem to different situations. The first question we have here is talking about the distance between 2 points, which is something that's been covered previously in a module beforehand. But I want to find the distance between M and N. Okay. Normally on a graph, if we had a horizontal or vertical line, we could just count from one point to the next. However, on a diagonal line, that is something we are unable to do, as it doesn't give us an accurate measurement. What we're going to need to do is we're going to need to create a right triangle on this graph, which we can do thanks to point P by drawing a vertical and horizontal line. Okay. By doing so, this makes a right triangle, and we can count our side lengths. We can find the measures of the legs and use that to find the hypotenuse, okay, which is the distance between points M and N. Okay, so from N to P, this leg right here, going from 4 to -4, is 8 units. From M to P, going from -6 to 5, is 11 units. Now that we know the two legs of the right triangle, we can use the Pythagorean theorem to solve. Okay, I know that my legs are 8 and 11. When I find the square, when I square these, I get 64 and 121. By adding these two together, I get an answer of 185. In order to find c instead of c squared, okay, the inverse of squaring and taking the square root. Okay, squares and square roots cancel out. Now I know that 185 is not a perfect square, and since it doesn't tell me specifically to give an answer to an approximate decimal place, we're going to leave that answer as the square root of 185. Okay, so the distance between points M and N is the square root of 185. Anytime that you're finding the distance between 2 points that results in a diagonal line, create a right triangle and use that to find your hypotenuse. Those parts, the vertical and horizontal sides, those legs, those will make the legs of your right triangle, and you are finding the hypotenuse. Number 2, it says, which 2 points are the farthest apart? Well, what's my distance from A to B? Well, yeah, that's a diagonal line, so I'm going to have to make a right triangle here. I'm going from 5 to -7, which gives me a side length of 12 units. And from -7 to -3 gives a side length of 4 units. So for AB, that distance is going to be, again, we're using this for all of our sides. So we're going to have 12 squared plus 4 squared, and we're finding the hypotenuse. 12 squared is 144. 4 squared is 16. When I add those together, I get 160. Again, to solve for C, to undo the square, I'm going to take the square root. And since I know that 160 is not a perfect square, I know that my distance here between A and B is the square root of 160. To do the same thing for B and C, again, we have a diagonal. So I'm going from -3 to 5, which gives a measurement of 8. I'm going from 3 to -7, which gives a measurement of 10. So I'm going to have a triangle that is an 8 and a 10. So I have 8 squared plus 10 squared. Those are my legs, okay, because I'm finding the hypotenuse. 64 plus 100 equals c squared. Okay. Once I square them, I'm going to add them together. And then again, to find the c, I'm going to take the square root. So the squares and square roots will cancel out, and I have, again, a non-perfect square. Okay, so I have BC is the square root of 164. The last measurement we need to find is from A to C. That means I'm going to go from -7 to 5, which again, that's 12. And from 5 to 3 is a measurement of 2. So I have 12 squared plus 2 squared for my legs. And I'm finding the hypotenuse. I'm finding that distance between the two sides. Okay, squaring 12 and 2 gives me 144 and 4. Adding them together gives me 148. Take the square root to undo the squaring of c. 148 is not a perfect square again, so we have AC is 148. And, well, if I'm comparing the 3 square roots, I notice that this is the biggest number, which would indicate the largest distance or the farthest apart. Okay? So the points that are farthest apart are B and C. Okay? It says explain as well. Well, by using the Pythagorean theorem to find the distances between each set of points, we determined that B and C are the farthest distance apart. Okay. Again, if you're finding a diagonal distance on a coordinate plane, use the Pythagorean theorem, or a diagonal distance anywhere. Use your Pythagorean theorem to find that measurement. All right. Question 3 is asking, is this a right triangle? Well, in order to see if it is a right triangle, we need to use the Pythagorean theorem to prove true or untrue. We need to know the measurements of each of these sides. Well, again, they don't tell us, and we have no vertical or horizontal lines, so we're going to have to create our own. Okay? So if we're going to look here, we're going to go and make this triangle, make your horizontal, make your vertical to find AB. Okay? So right here we have a measurement of 8 because we go from -8 to 0, and from 7 to 4 we have 3. So we're going to have 8 squared plus 3 squared, which gives 64 plus 9. And when you add together, that gives 73. Take the square root to remove the square from C. Again, 73 is not a perfect square, so we're going to say that AB is the square root of 73. Okay. BC, we're going to go from 7 to 1, so that's 6. And from -8 to -5, which is 3. So we're going to have 6 squared plus 3 squared. 6 and 3 are my legs, which gives 36 and 9. When I add those together, I get 45. Take the square root. And 45 is not a perfect square. So the square root of 45 is this measurement. So now I've got a hypotenuse and a leg. I've got to determine if this leg itself too. So from -5 to 0 is 5. From 4 to 1 is 3. Replace there for the legs. 25 plus 9 is 34. Take the square root to determine C. And 34 is not a perfect square, so I have the square root of 34. Now that I have all three side measurements, I can use the Pythagorean theorem to determine if we do have a right triangle. Remember, when you're trying to figure out which side matches which variable, your legs are A and B, and your hypotenuse is C, which is the longest side. In this case, they're all square roots, so it's easy to compare. Okay, 73 is the biggest, so my legs are going to be the square root of 45 and the square root of 34, and the hypotenuse is the square root of 73. Again, remember, squares and square roots cancel each other out. Okay, they're inverse operations. So essentially we're getting rid of the square root symbols, and we have 45 plus 34, which adds up to 79. And since 79 and 73 are not equal, this is not a right triangle. It is a triangle, just not a right triangle. Not a right triangle. Okay. Question 4. 4 and 5 are going to be giving some real-world examples here. Number 4 talks about a rectangular field. Dylan walks the sidewalk, which is the outer part here of this field. And sometimes Dylan walks diagonally across the field. Okay, well, the diagonal here, because we see that we have a rectangle, and rectangles have right angles for each angle. This diagonal represents the hypotenuse of a right triangle. We got to figure out which distance is shorter. Well, Dylan's route on the sidewalk, he goes 120 and he goes 80. So Dylan's sidewalk route is 120 plus 80, which is 200 yards. We have the legs of a right triangle that we can use to figure out what Dylan's route across the field is. So we know the two legs, and when you square these, you get 14,400 plus 6,400. When added together, it gives you 20,800. And again, to eliminate the square on C, we're going to take the square root. Squares and square roots cancel out. Okay, so you can bring out your calculator here, because even though this is not a perfect square, we need to find a distance to the nearest tenth. Okay? In this case, we are just going to use the calculator. Most of you are probably going to type in second and hit the square root button, okay, which is going to be right above the squared. Okay. And then we're going to type in our number, 20,800. And when we do, we have an approximate answer of 144.22205. And it's going to keep going. However, okay, it says round to the nearest tenth. So rounding to the nearest tenth, we would say 144.2. Okay, so Dylan's route across the field is 144.2 yards. Well, which distance is shorter? Okay. The distance across the field is shorter by, well, we're going to take 200 minus 144.2, and that's going to give us an answer of 55.8. Okay, so by 55.8 yards. You just use Pythagorean theorem and kind of just compare those routes. Number 5 has a wheelchair ramp. We have to determine if the ramp meets the guidelines. The guidelines say that for every 1 foot of height on the ramp, the base must be at least 12 feet. Okay. So this is not drawn to scale. So I know some of you are thinking, well, that's 1.5. That's definitely not 20 or vice versa. We know it's just an example. It's just a picture. If I have a 1.5 foot high ramp, how long should the base be? Well, 1.5 times 12 is 18. So we need to make sure the base is at least 18 feet. In order to do that, we're going to have to use, you guessed it, the Pythagorean theorem. Okay. In this case, I am given the hypotenuse because it is the side that is across from the right angle. Okay. Also remember, the legs of a right triangle come together to make the right angle. So I have one leg and the hypotenuse. And if you wanted to write 1.5 for A and have B be the missing base of the ramp, that would be okay too. Okay, so if I take 1.5 squared, that's 2.25. And 20 squared is 400. Okay, if I'm going to figure out what this missing piece here is, I got to isolate my variable. Okay, subtract from both sides, which gives 397.75. Okay? And again, we need to take the square root so we can figure out what exactly we have as our measurement to see if it fits. Because if we just leave this as 397.75, we leave it as the square root of that, we don't know if that meets the qualifications or not. Okay? So we're going to have to, I guess if you knew what 18 squared is, you would know whether that would qualify or not. But we're going to go ahead and figure out what the square root of 397.75 is approximately. So approximately, it is 19.9 feet. Okay. So this is approximately 19.9, and we said it needed to be at least 18. Well, it's not 18, but it's more than 18. At least means it should be 18 or bigger. So the ramp does meet the ADA guidelines the ramp needs to have a base of 18 feet or longer, and the base is 19.9 feet. The ramp does meet the ADA guidelines. The ramp had to be 18 feet or longer, and the base was 19.9 feet, so that checks off the box of a correct ramp. Number 6 is asking us to find the area of this right triangle. Or it's giving us the area of the right triangle, sorry. It's asking us to find the perimeter. Well, to find the perimeter, I need to add up all the sides. The problem is I don't have all of the sides of this triangle. I do know the area. Okay, well, area of a triangle is base times height divided by 2. I know that one of these is 6.3, and we'll just call it the height. It doesn't matter. And I do know that my area is 26.46. So we can find this side here, which is the leg, by finding the height. Well, I'm going to take 6.3 divided by 2, which is 3.15. So 6.3h divided by 2 is 3.15h. And then in order to continue to solve, I'm going to divide both sides by my coefficient of the variable. Okay, so I'm dividing by both sides by 3.15. And when I do that, I get a height measurement of 8.4. Okay, so this leg over here is 8.4. Next, I need to find this measurement on the triangle. Well, it's a right triangle, and I have the legs. So therefore, I can find the hypotenuse here of this right triangle. I know that my legs are 6.3 and 8.4. So when I take the legs and square them, 39.69 plus 70.56. And when I add those two together, I have 110.25. Again, I need to take the square root of both sides in order to solve for that hypotenuse. And since I know that 110.25 is not a whole number perfect square, I'm going to put it in the calculator, and I'm going to see, let's see that I get 10.5. So even though it's not a whole number, I would think of it as a perfect square because I can get an exact answer. If you can't get an exact answer, that's when I would say not a perfect square. Some people are going to argue because it's not a whole number, it's not a perfect square. Just going to be how you decide to look at things. But I do know now that this measurement is 10.5. And since I need to know the perimeter, I need to add up all the sides. Well, if I add up the sides, that gives me 14.7 plus 10.5 is 25.2 units. So when we were working this out, we wanted to know the perimeter, but all we were given were the area and one side. Okay, we had to figure out all the sides of the triangle to find the perimeter. So we used the area formula of a triangle to solve for that missing measurement, okay, the missing height or leg of the triangle. And once we had both legs, we could use the Pythagorean theorem to find the hypotenuse. And once we had all three, then we could add them up to find our perimeter. Last question here, number 7. It's asking is ABC, so it's talking the whole big triangle. Is that a right triangle? Okay, well, I need to be able to know all three sides of this triangle. I know what this side of the triangle is. I know AC. I don't know BC, and I don't know AB. I know part of that, but I still need to figure out this part right here, and I need to figure out AD, because that will then help me find the whole measurement here of AB. Okay. So if we're going to find CB, okay, again, we have a right triangle, so I can use the Pythagorean theorem here. I can say, 6 squared plus 9 squared equals C squared. Well, 36 plus 81 gives me 117. And in order to figure out what C is, instead of C squared, I take the square root. 117 is not a perfect square, so we're going to leave it as the square root of 117. In this case, I don't need to use these two to find this. Okay? But I do need to figure out what AD is. Because I have a triangle that's got a height and makes a right angle on this side, that's going to make this a right angle on the other side as well. So we can say that this triangle as well is a right triangle. So we can use the Pythagorean theorem. And I know that I have a leg and the hypotenuse because the two legs make the right angle and the hypotenuse is across from the right angle. So in this case, I have 6 squared plus b squared, or you could switch those up, equals the square root of 52 squared. 36. We don't know what b squared is, and 52. Squares and square roots cancel each other out. Okay. To get b all by itself, I'm going to eliminate the constant, which tells me that b squared is 16. To solve for b, I'm going to take the square root, and since it is a distance or a measurement, I know that it is the positive, which is 4. Now I have this part. If this is 4 and this is 9, then the whole thing, and add them together, is 9 plus 4, which is 13. I now have all three sides of this triangle. I can use my Pythagorean theorem to determine if I have a right triangle. I need to know, though, which one of these three sides is the biggest. Well, we already know that this side is 13. So if I take the square root of 52, I get 7.2. If I take the square root of 117, I get 10.8. Both of those are smaller than 13. So 13 is going to be my hypotenuse. So the square root of 52 squared plus the square root of 117 squared is equal to 13 squared. Well, these parts are easy because squares and square roots cancel each other out. And we should know the square root, that 13 squared is 169. So when I add them together, I get a true statement. So triangle ABC is a right triangle. Okay. And we would just say, when using the converse of the Pythagorean theorem, the squares of the sum of the squares of the legs was equal to the square of the hypotenuse. In this case, we had to find the missing parts of the triangle to get all three side measurements to then determine, okay, is this in fact a right triangle?